Lesson 5.1 is functions. I would pause the video and write down these notes. So a relation is a set of ordered pairs x, y that specifies corresponding values of independent and dependent variables, and we represent these with context, graphs, equations, tables, or mapping diagrams. So a graph is a visual representation to represent the two variables. Plot your x and y coordinates with your x-axis and your y-axis. A mapping diagram is something that looks like this. So you have a set of your independent variables and you have a set of your dependent variables, and there's some relation that takes all the elements in your inputs or your independent variables and maps them onto the set of your dependent variables or your outputs. A specific output is called the image. So for example, the image of 2 is 12. And then you also have a table. Here are some more definitions. I would pause the video and write down these definitions. So while a relation is more general, it can be any relation between x's and y's. A function is more specific. It has every element in the first set of your inputs, your independent variables, mapped to one and only one element in your y's, or your second set. So every x has a unique y. A one-to-one function, not only does every x have a unique y, but every output is also mapped from one and only one input. So every y only has one x coordinate. A visual way that we can test to see if a graph is a function is the vertical line test. So I have these three little graphs here. The very first one, if I draw a vertical line on this graph, it intersects twice, which means one x value goes to two different y values. So this is not a function. The second one, anywhere that I draw a vertical line, it'll only intersect the graph in one place. So this is a function, but there are two different x coordinates that give the same y coordinate. So it is not a one-to-one function. This third one, not only is it a function, every x only has one y, it's also a one-to-one function because every y only comes from one x. Domain is the set of all your inputs or possibles of your input values. The range is the set of all possible output values. The notation that we use for functions is this f of x notation, or sometimes different letters, but y equals f of x means that x's are your domain variable, and they're mapped through the function f to your y's or your ranges. It's read as f of x. It does not mean f times x, so be very careful. If you have a function here and it says f of x is equal to 2x plus 5, then if I ask for f of negative 1, that means that x is equal to negative 1. What is your y value? Here are two little mapping diagrams that also just show a one-to-one function. Every element in your inputs goes only to one element in your outputs, versus a not one-to-one function or a many-to-one function. There are two different elements in your inputs that go to the same element in your outputs. So here's an example. Paula is working on an environmental project and is analyzing the amount of paper used to print books. She finds out to print one copy of a certain book, it takes 6 meters squared of a particular type of paper. So let A be the set of all number of copies of the book, 1, 2, 3, 4, 5, so 1 copy, 2 copy, up to 5 copies. And B is the set of amount in meters squared of paper needed to print the book. So 6, 12, 18, M, and N. So when you have one book, it takes 6 meters squared of paper, so on and so forth. So using that, find the values of M and N, and then write down the set of ordered pairs for this relation. So if it takes 6 meters squared for every book that's made, if you're making 4 books, it would make 4 times 6, so M would be 24. And if you're making 5 books, it would be 5 times 6, so N would be 30. So then your coordinate pairs, you would just write them as 1, 6, 2, 12, 3, 18, 4, 24, and 5, 30. So this is a relation that represents paper to, or books to paper. So here's another example. Consider the set A, which is negative 3, negative 2, 0, and 2, and the mapping x goes to 2x squared minus 1. So this is a different way to kind of write relationship notation. So this is saying when you plug in an x, the y, or the output, is 2 times whatever the x is squared minus 1. So first thing we want to do is we want to find B, which is the set onto which A is mapped, so basically the set of outputs or y values, and then determine whether or not this mapping is a function from A to B. So once you have that, is this relation a function? So go ahead and try number 2. So I'm finding the set of the outputs are basically the y value, so I just plugged every x value into our little mapping notation here, and I've solved for y. So when you plug in -3, you get 17, -2 goes to 7, 0 goes to -1, and 2 goes to 7. So every x only goes to one y coordinate, so it is a function, but it's not a one-to-one function. Because -2 and 2 both go to the same y value, it's a function, it's just a many-to-one or not a one-to-one function. The next example, we're given a graph of a relation. Note that the graph has a solid dot here at x equals -2. That means that that value is included in the graph. But here at x equals -1, it has a hollow dot or an open circle. That means it's not included. So explain why this is a function and then find its domain and range. So go ahead and pause the video and do number 3. So it is a function because every x value only goes to one y value. It would pass the vertical line test. Anywhere you draw a vertical line, it would pass through the graph only once. The domain, I wrote it in both interval notation and inequality or set notation here. So our domain goes from -2 included, so or equal to or a bracket, up to 1 not included, so either a parenthesis or a strictly less than. And then for your range, you go from -1 included all the way up to +3 included. Consider the function y equals x plus 1, where -2 is less than or equal to x is less than or equal to 1. We want to find the image or the y value of x equals -0.5. Write down the domain, use your graphing calculator to help you sketch a graph of this, and then find the range of this function. So go ahead and pause the video and try this one. So if I plug in -0.5 in for x, you end up with -0.5 plus 1. So the image of x equals -0.5 would be 0.5. That's its y coordinate. The domain, they give us the domain. It tells you exactly where we want it to be graphed. So that is the domain of this function. Use your graphing calculator, or just the fact that this is a line, y equals x plus 1, and you want to graph it between -2 and 1. So at -2, it's at -1, and then it has a y-intercept of 1, it has a slope of 1, and it ends here at 1, 2. And then the range, the lowest it goes is -1, the highest it goes is +2. So either interval notation or set or inequality notation. So here's a similar question, except for this time it's in function notation. So consider the function f of x equals x squared plus 1. Part A says find the value of f of 2. Part B says find the image of x equals -1. And part C says determine whether the point 5, 26 lies on the graph of the function of f. So go ahead and pause the video and try this example. So f of 2 just means whenever you see an x in the original function, replace it with 2. So you end up with 2 squared plus 1, which is 5. Find the image of x equals -1 means find the y coordinate when you're given x is equal to -1. It's pretty much the same question, just a different way to ask the same question. So again, plug in -1 every time you see x. Be careful on this one, it's -1 quantity squared, which is a +1, plus 1 is 2. And then determine whether 5, 26 lies on the graph. So basically, does it make the equation true? So I plugged in 26 for f of x, and I plugged in 5 for x. You get 5 squared plus 1, which is in fact 26. So yes, 5, 26 is on the graph. So our last example, we are going to be modeling. So in this chapter, as throughout the whole year, we're going to be doing a lot of modeling, which is a suitable mathematical representation of a particular situation. So it says the price in dollars of a motorcycle T years after purchase is modeled by P of T equals 15,000 minus 2,500 T for T between 0 and 6. So we have part A, we want to state the independent and dependent variables. So what are these representing? B, find the value of P of 0 and what does it mean in context. Find the price of the motorcycle 1.5 years after purchase, that's C. D, find the value of T for which P of T equals 6,250 and interpret. E, comment on the case T equals 6, and then part F, sketch a graph. So go ahead and pause the video and try this last example. So for part A, the independent variable is T, which represents time in years, and the dependent variable is P, which represents price or worth after a certain number of years. Part B, P of 0, so I plugged in 0 for T. I got 15,000 minus 2,500 times 0, which is 15,000. So at time 0, it was worth $15,000. So basically, the motorcycle cost $15,000 when it was purchased. Find the value for part C of the price of the motorcycle 1.5 years after purchase. So I plugged in 1.5 for T and got $11,250. Find the value of t for which p of t equals 6,250. So I plugged 6,250 in for p of t, and I solved for t. I subtracted 15,000 and then divided by negative 2,500 from both sides and got t to be 3.5 years. So after 3.5 years, it'll be worth $6,250. Comment on the case of t equals 6. So if you plug in 6, you end up with $0. So basically, this is a depreciation. It gets worth less as time goes on. So after 6 years, it'll completely have depreciated. The motorcycle won't be worth anything anymore. And your little sketch here, so I have a y-intercept of 15,000 when t was 0 is 15,000. I have an x-intercept of 6 because at times 6 it was 0, and then it's a straight line depreciation. So this has been lesson 5.1, Introduction to Functions.